We're going to solve this differential equation. Y prime is equal to y squared minus 4. This is a separable differential equation. We can write it as dy divided by y minus 4. On the right-hand side, you have dx. Well, now that it's a separable differential equation, we can take the integral of both sides. The integral of dy divided by y squared minus 4 is equal to the integral of dx. Now, how do you find the integral on the left-hand side? To calculate the integral on the left-hand side, we're going to use the method of partial fractions. 1 over y squared minus 4 can be written as 1 divided by y minus 2 times y plus 2. The method of partial fraction helps us to separate this into the summation of two fractions. 1 divided by y minus 2 times y plus 2 is a divided by y minus 2 plus b over y plus 2. So basically, you can switch these two as well if you want to. Eventually, you get the coefficients that are associated to each denominator. Now, to find a and b, you're going to take the common denominator between these two, which is the multiplication y minus 2 times y plus 2. So on the numerator, you're left with a times y plus 2 plus b times y minus 2. The denominators are equal to each other, so the numerators must be the same as well. If you set the numerators equal to each other, on the left-hand side, you have 1. On the right-hand side, you have quantities including y, variable y as well. So in this step, let us just distribute a into parentheses. You get ay plus 2a plus vy minus 2b. Please note that on the right-hand side, you have some y terms. On the left-hand side, there is no y. It means that the coefficient of y was 0. You end up with a plus b equal to 0 and 2a minus 2b equals to 1. This is a classical way to solve this equation. Again, on the right-hand side, you have ay plus by. On the left-hand side, there is no y. It means that the coefficient of y was 0. So if you add ay plus by and factor out y, you get a plus b. It must be equal to 0 on the left-hand side. That's how you end up with 0. And the constant 2a minus 2b is equal to the constant on the left, which is 1. When you solve this system of equations, a becomes 1/4 and b becomes -1/4. So by the method of partial fractions, you could separate this fraction into the summation of two simpler fractions. 1/4 over y minus 2 minus the 4th divided by y plus 2. Again, this is called the method of partial fractions. So let us move on and calculate the integral on the left. It is the integral of 1/4 over y minus 2 minus 1/4 divided by y plus 2 with respect to y. And on the right-hand side, you have the integral of dx. So again, this fraction is broken off into the summation of two other fractions, simpler fractions, by using the method of partial fraction. The question is, how do you calculate the integral on the left? We're going to go back to calculus and use the formula, the integral of 1 over u du, which is ln of absolute value of u plus c. So in solving the differential equation, so far we have the integral on the left and the integral on the right-hand side. 1/4 is basically a number, a coefficient. You can write it in front of your integral. So you're calculating the integral of dy over y minus 2, which is 1/4 ln of absolute value of y minus 2. Remember that. We calculate the integral of dy divided by y minus 2. we are using the calculus formula. Using u sub, the integral of du divided by u is ln of absolute value of u plus c. The second integral is negative a fourth, the integral of dy divided by y plus 2. With the same process, it is going to be negative a fourth, ln of absolute value of y plus 2, following the formula that we saw in calculus. On the right-hand side, you have the integral of dx, which is x plus constant of integration. Let's call it C1, because later on we're going to simplify this more, and we're going to relabel C1 along with other functions. Let us factor out 1/4. You have 1/4 ln of absolute value of y minus 2 minus ln of absolute value of y plus 2. So 1/4 was the common factor here. On the left-hand side, you just factor out 1/4. On the right-hand side, you just copy down x plus c sub 1. Multiply everything by 4 and use the properties for ln. You get ln of absolute value of y minus 2 divided by y plus 2, which is 4x plus c2. So note that I multiply 4 on the right-hand side, 4x plus 4c sub 1, which I now relabel to c sub 2. And again, please remember the properties for ln. ln of a minus ln of b is ln of a over b. Very good. So we're ready for the next step in solving the differential equation. Here we have ln of absolute value of y minus 2 divided by y plus 2, and on the right-hand side, we saw it is 4x plus c sub 2. Well, this can be written as the absolute value of y minus 2 divided by y plus 2. And on the right-hand side, you end up with e to power 4x plus c2. On the left-hand side, you have ln, which is logarithm with basis e. So the quantity is equal to e to power 4x plus c2. You can get rid of the absolute value. You get y minus 2 divided by y plus 2. On the right-hand side, you get plus minus e to power 4x plus c2, which in turn can be written as plus minus e to power 4x times e to power c2. Now the question is, how do you isolate your y? In general, if you have y minus 2 divided by y plus 2 equals to a quantity like m, to isolate y, you can cross multiply. You get y minus 2 equals to m times y plus 2. Y minus 2 is equal to my plus 2m. We just distribute m into parentheses. And y minus my, bring all y terms to one side, is equal to 2m plus 2. Now, if you factor out y, you get 1 minus m equals to 2m plus 2, or your y can be isolated on one side as 2m plus 2 divided by 1 minus m. So this helps us to isolate y and have an explicit solution. In turns, it can be written as y equals to 2. This is your, can be considered as your m, or you could use c as plus minus e to power c2, and c times e to power 4x is your m. Just substitute that here, and y becomes 2m plus 2 divided by 1 minus m, which is basically y equals to 2 times 1 plus. Here you have your m, which is c times e to power 4x divided by 1 minus m, which is c e to power 4x.